with how the process got started by including people in the process. And one of the hourly assembly workers kind of educated me very quickly by saying, you ask all these stupid questions, you write all this standard work, and it means nothing to us. If you just put a picture of what one good part looks like and one bad part looks like, we can make the good part all day long. So I got this idea, and tied it to the book that was given by Dr. Murdy and Dr. Ali that, I need to practice this in our plant. So I did. And the more I got involved and the more I saw the power of the team coming together, I started understanding what the Toyota production system, what the Toyota business system was, and the power of that. And I realized it was what I called the secret sauce. It was going to be the secret sauce for me being a successful supervisor, manager. And my career grew to running operations, plants, and companies. But the more I learned about those tools, they gave me the foundation for my entire career, and probably everybody that I know that's in that same career or related career, because it's a business model and it's probably one of the best. And I'll give you some anecdotes maybe a little bit later I was at the Shingo conference last week, talking to some very mature, PhDs and people that are involved with the lean world. And it's interesting because the problems are still the same 30, 60, 70 years later, just people call things differently, but still the same problems.
Yeah. And that sort of insight that, sharing, just simply sharing with the people doing the work, the difference between right and wrong, and making it somehow visual. There's a human quality to sort of doing that. And I know you're now in, this sort of big interface between, lean and sort of technology, and how technology can help things. So that's a long, that's a big spread, right? So,
Absolutely.
So what is technology doing for us now?
So let me give you an anecdote. On the healthcare side, if you went to an emergency department or an ED at a hospital, the patient presents at registration, and in reality, you're going through these vertical silos of departments. So, HR often runs, the admin at the front desk at admissions. Then you have another group that ties to rev cycle, kind of in the financial, taking your information on insurance and et cetera, and for payment. And then you're going to get triaged depending on the acuity, the intensity level of your, let's say, injury. And then you navigate through this series of vertical silos. You may have to go get blood tests, other types of x-rays, things like that. They have to go to these ancillary departments and processes. And at some point, depending on your wait time and how many times you get moved, how many times you get handed off, and where you end up, you should be in and out in about 30 to 45 minutes, but the systems don't interrelate and talk to each other. So what's happening today, which is kind of exciting, is artificial intelligence and analytics, kind of going back to the statistical tools you were talking about. Yeah. So you're taking all these statistical tools that you're learning and all these other analytical tools that are, automated, and you're learning, and you have a bunch of information that you just mentioned earlier in the class that tells you where some of the issues may be, based on data and material information. And that it doesn't necessarily help real time, but it helps in recorded history of multiple patients navigating through the process. Then the AI comes into play, takes the analytics and narrows down the gaps, if you will, based on this gap analysis, and narrows down the potential, and it starts predicting through like Pareto diagrams, if you will, predicting where the failures are going to come based on data. So as an example, before we had all this, these tools and technology, when I worked at a hospital in an ED, everybody would say, well, it's different all the time. We get slammed. We don't know demand. And I said, no, it's predictable. I can tell you have patterns. They're probably 5, 6, 7, 8, 10 years. If you take that data, and sure enough, we did, and we manually crunched all the data, and we found that we had very specific patterns. More injuries happened on the weekends because they were close to a bunch of lakes. This happened to be in Napa Valley, and the Napa Valley Hospital. I won't mention the name, but they also determined that particular days of the week were the highest, and particular times during each day varied, but at which were the highest. And then what we started doing is staffing their ED so they had the right number of staff. Why did we do that? So the patients could navigate through the process, because one of the root cause reasons was not having enough staff at high demand.
Yeah. It's interesting, you're sort of tying this back to like your original story about, just telling people the difference between good and bad. We still maybe have a standard for what we want to do, like good, as far as the value to the customer piece. Now we got a lot more information on, not necessarily bad, but just sort of how we're doing against that standard, right? You get that either historical or real-time measurement that we can say, okay, we know what good is. Here's how you're doing against that a little bit more, so people have more information to evaluate.
Absolutely. I mean, when I started, back in the 90s, late 90s, doing more and more of that work, we didn't have a lot of the technology. We didn't have a lot of the analytic tools. We didn't have AI, available to us. So we had to do everything through observations. We had to do it through number crunching and, a lot of statistics, and various other tools and methodologies. But today we come to play with a lot of that information. So it becomes more maybe problem solving, because you have all the data now. You don't have to spend as much time collecting the data.
Yeah.
You're now spending more time problem solving. And
Right.
and then you tie it to, so in any operation, no matter what career you're going to go into and what you're going to do, there's always going to be three big things. There's people, a culture of an organization, and the people that play in a part of it. And that's so important. And Masaki Imai, by the way, was one of my senseis. So I worked with Toyota and I supported Numi and the Toyota of Japan. And he was one of my senseis. So one of my great, I got to read his book and I got to work with him, and I got to work with James Womack and others like that. So what we realized from the Japanese and Toyota was you had to understand people as much as you had to understand all the tools. So we kind of framed it people, process, purpose on a pyramid, three big points. So you had the people and the culture of the organization. You had the process, which is all the tools that we're talking about and all the things you need to do to solve problems. And then you had the purpose, think of that as a strategy, the mission, vision, and values, and the strategic initiative of the organization, no matter what kind of company it is, and profit or nonprofit. And the idea is you have to tie those three things together. So now that we have more data and the process is becoming a little bit easier and the tools are more common, you're really having to rely a lot more now on the human piece, because what you find in that ED flow of patients, this is where our company comes in, the service side, because if you have people that understand clinical applications and the lean tools very well, they can start taking that data and helping close the gap much quicker and training the staff on what to see and how to see and learning to see.
The students here, our approach here at Cal Poly is, we're doing the Lean Six Sigma green belt body of knowledge, and it's a DMAIC sort of underline, right?
Right.
And there is a big focus and intensive amount of emphasis on that measure piece.
Yes.
But as you talk, I'm thinking, well, is there a time spent in every one of those 5 phases of the DMAIC process, and maybe we can spend less time in the measure if that data is already there or readily crunched and available. We can spend more time on the the analyze and the improvement sides of things and making sure things happen.
Absolutely correct. So as technology and data and information becomes more prevalent, you spend less time in some areas and more in the others, and that's absolutely correct.
Yeah. So I want to encourage the students to get in here and ask some questions. So it's not just John's voice and my voice, in here. We'll get some other voices and folks on the screen. So if you want to ask a question, go ahead and type a question in the chat, or you can go ahead and raise your hand so we get some other folks in here. So as folks are sort of formulating those questions. So John, my next question is, do you have like a current sort of big lean challenge that you're either working on or seeing a lot, or can share with us and the students here?
Sure. Again, I'll frame it kind of people, process, purpose, but one of the big challenges is as lean becomes more mature in a lot of industries like manufacturing, aerospace, for example, or automotive, and even healthcare is moving towards the maturity curve. everybody thinks they know everything, right? We get a certification, we get trained, we know a few tools, and now we know everything. What what happens, like anything else, the Japanese senseis, they had 20 and 30 years of experience before they really started doing a lot of these things, of experimentation. So there's the challenge is you're now working in mature markets, and you have to move to and service those mature markets. It's not ground zero anymore where everybody's learning baseline tools. It's you're working in mature markets where almost everybody knows, some tool, the DMAIC process, the statistical tools, the lean tools, the waste reduction tools, for example. And so they want to know and learn different things and more things.
Yeah.
On the technology side, it's hard for the technology folks to imagine that you can integrate lean and technology, and that you don't want to apply new tools and software and other programs on top of waste. So an operating system, an ERP system, a lot of times when you put it in, I remember, putting in Oracle and other SAP in my operations, and I typically had to hire more people. And I was running a lean shop, and I had to hire more people because we had to do more administrative and more, types of processes that required, different skill sets. So the other challenge is getting everybody to understand that just because you're putting in an operating system that's being sold as, the end all, that there's going to be challenges because you're putting typically a process on top of maybe bad systems, bad processes.
Right.
So you may want to lean them out first. So that's educating the population on that. And then the third, I think, is that people don't necessarily understand in general the value of process improvement and how important processes are when, in theory, I was at a hospital, an oncology center, a real famous one here in California. And somebody was asking me, what do you do? And I was sitting in an infusion center where a cancer patient would be getting an infusion. And I said, well, open your drawers. And this is a supply chain issue, similar to Timothy's label challenge. And the idea is what's in there. You should have a par level or set level, and with barcode on everything that you have. And they didn't. They just crammed parts in there. And I said, components and supplies. And I said, well, your inventory system tells you you have X, Y, and Z par level in these parts in this center, in this area, in these rooms. But in reality, you don't know what's in the drawer. And so you're losing materials are gone, you have lead time issues, and all you're doing now is you're expanding the supply chain and you're causing problems. Now they understand the software and how they're supposed to use it, but they're not seeing the problems by their actions and what they're doing that's circumventing it and causing more issues. So it's not being used properly.
Yeah.
Hopefully that makes some sense.
Yeah, no, it's that so many of the challenges I think we find in the lean field too is that are those interface areas, either interfaces between the silos or interfaces between sort of the technology, the data available versus how the people are using it, or those sorts of things. So I think that's a good insight and a good lesson for the students to take away.
Yep.
Okay.
So
right.
it's a balanced approach.
Well, John, so I'm looking for my students to sort of help me out here with additional questions. So I usually got a few folks that are willing to sort of jump in. You might be intimidating them a little bit too much, So, it's interesting. Oh, we got a in-class question. Hold on a second. I'm gonna go ahead and bring my do a little camera work here.
Sure.
All right. So could you go ahead and state your name before you?
Hi, Mr. Rubio. My name is Evan Sukahara. Basically, the reason that I took this class specifically is I was really excited about hearing that lean is really applicable in the real world. And you were mentioning earlier in your talk that you feel like you have to basically go back to school and relearn all this lean principles. So basically, what I was wondering is, was that in a literal sense, or was that more metaphorical, or do you really think that what we're learning in the class today could be brought back into any workplace, whether it be, like you said, aerospace or medical or even business?
Yes, absolutely. So let me say this, and I've spoken to several MBA courses at other universities, and and I've presented, papers at different conferences. Let me say this: the best education you can get is what you're taking right now. This class, this process. It's a business model. It's going to help you in whatever field you go into. It's applicable to anything and almost everything that you're going to touch in your future. So it's absolutely not a waste of time. Probably one of the most valuable classes, and quite frankly, it probably helped me get to where I got to in my career, because I could problem solve, I could see things, I could understand things, I could communicate with people in different ways. I had different tools that I could bring to the table that no one else, a lot of my peers didn't have, that didn't take these type of classes in these programs. So what you're getting now, I've told people for the last 20 years, it's probably one of the most valuable things you could take. So I'm not learning lean all over again. I'm still teaching what we were teaching 30, 40 years ago. What I'm learning is new technology. What I'm learning is things that are new to me. I didn't work in the technology field. I'm not a programmer. So I'm learning. I hate to say this because it ages me, but the first computer, my first computer was an Apple, when it first came out, from Stephen Jobs, and the cell phone, the first cell phone was a Motorola that was about the size of a brick that you held up to your head. So, that's the level of technology when I was growing up and going to school. So, the world's changing every day, every week, every month. I used to do training and talk about the rapid amount of changes happening. There was a change curve. You've seen the poster where it goes from caveman, it goes almost vertical. Well, now it literally is vertical. And, your new cell phone is being, redesigned every 3 months. When I was in the auto industry, the average turnaround for a new design of an automobile to being released to the public at a dealership was somewhere around 8 years to 9 years. And the standard had been 10 years when I got into the industry. When I left, we were between 24 months and 36 months, and today it's less than a year. So that's how much technology has advanced. If you go to the Tesla plant, it's a lot of robots instead of people. I used to work in the plant that had all the people. Now 50% of the plant is robots. So you have to understand the PLCs, the programmers. You have to be able to program them. You have to understand the language, the interfaces, and then the really neat technology. How do you tie that to TPM? So we're writing software that basically is a part of TPM that's interpreting or predicting the failure of a machine by the temperatures it's running, the cycles it's run, the different sounds it makes, the oil pressure, the oil temperatures. So all the different, those are the things that we're learning now today, is how to integrate those technologies we played with, years ago, but with technology, how you can somewhat automate them. So that's the learning curve. But what you're taking right now is not a waste of time. Trust me. It is one of the best things you could do.
Yeah.
I didn't mean to imply with waste of time. I was just wondering how much it's used, but thank you for answering my question.
Sure, absolutely. Hopefully they answered.
Yeah, no, that was a good answer, John. And John, so one of the things I've been trying to do on my lean celebrity interviews is try to, stay within the time span of student absorption, which is, about 30 minutes. Right. So I'm gonna try to wrap things up now at this point. And John, it's been wonderful talking to you and catching up once again. I always learn something from talking to you. But for the students here, we're just starting out on their lean journey. Do you have what sort of that one piece of advice that maybe you wish your sensei had told you, way back in the day? What would that piece of advice be for these guys?
It's frustrating sometimes, and there's always constant. You're going to find that in life in general, but when you get into process improvement and you're creating change, you're touching on the human emotion and people, and they told me that. But you don't realize it till you get in the middle of a room with heated people, that they're pushing back, because the paradigm, the area you want to shift them to is out of their comfort zone. So if anything, be patient, and go back to the tools and the science and the basics. And as Masaki Mai and other senseis taught me, always go back to the basics because it'll hold and ring true. And change is hard. No one likes to change. No one on this call wants to change, but we're all I'm being forced to change, to learn and merge technology to, old school principles, and to make it work. It can be challenging at times, but stay the course and learn to be patient and go back to the basics and what you've learned and what you'll learn in this class.
Boy, John, that's great advice, and I'm glad you're the cleanup batter for our lean celebrities this quarter.
Okay.
So if that's the last thing that the students walk away from as far as advice for lean celebrity, it's pretty darn good advice, and I really appreciate you doing that. Okay?
You're welcome. You're welcome.
Right. And John, just to show our appreciation, so we've got a tradition. If you want to go ahead onto gallery view, I'm going to ask the students to pop on their videos, give you a little wave in appreciation, and thank you so much for being here and doing this. These are some of the faces and the people that you've affected today. So John, thank you very much.
Thank you. Appreciate it.
All right. Take care of yourself.
Absolutely. Take care.
All right. Bye-bye.